Protected areas are a cornerstone of conservation, and we all depend on them. Today they are expected to meet a wide range of objectives. These do not only include the protection of biodiversity, but also other aspects, like the provision of ecosystem services or the protection of our climate. To allocate sparse conservation funding, and also to unite international conservation efforts, it is becoming increasingly important to optimize the strategic selection of sites towards different objectives. Optimizing the selection of sites for conservation towards more than one conservation goal can increase the efficiency of a protected area network. But the prioritization of different conservation objectives depends strongly on the values and demands of the different societal groups involved in the site selection. Different stakeholders are very likely to have different priorities, and therefore the selection of sites is often a value-based decision. And finally, the purpose of conservation has been transient over time, and expectations towards protected areas are likely to change gradually from one generation to the next. All of these points highlight the need for a flexible site selection approach, where different conservation objectives can be explicitly considered and weighted individually against each other. Here we present a flexible approach to site selection for conservation. We developed a decision support tool that helps comparing different objectives, facilitates discussions, and also allows for a transparent site selection approach.
The tool includes the following conservation objectives: high biodiversity, ecosystem integrity, climatic stability, land use stability, climate protection, and area size. Each objective is based on a collated set of macroecological indicators. For example, the objective biodiversity comprises the total species richness of birds, mammals, reptiles, and amphibians, their endemism, and their evolutionary diversity. The 6 different conservation objectives can be combined into different conservation goals as laid out in the figure. For example, biodiversity can be chosen as the only conservation goal. In this case, all other conservation objectives are disregarded. It is, however, also possible to rank ecosystem integrity high, which measures the intactness of an ecosystem. This is just another example. Actually, all conservation objectives can be included or disregarded in the weighting. Some of the conservation goals are based on data that are less susceptible to uncertainty. These are displayed in green in the sliders. Assumed climatic stability or land use changes involve somewhat more uncertainty because they are projected into the future. So they are red. Details about the data included in this list can be checked below. While you adjust the settings for the different weighting of the objectives, you can see the automatically updated site evaluation when clicking in the Site Evaluation tab. It shows the ranking of the protected areas based on the applied weights. The values for the different conservation objectives range from 0 to 1, with 0 being allocated to the site with the lowest score and 1 being allocated to the site with the highest score for the respective conservation objective. The values are scaled across all sites included in the ranking. This means that the scaled value that an area has for a particular conservation goal indicates the overall ranking of that area for that goal, as shown in the following example. If the weights for biodiversity and ecosystem integrity are both set to 50%, you will see that in the Talamanca range is the top site. This is because it has the second highest biodiversity among the included sites, with a biodiversity score of almost 1. But it also has a clear human footprint indicated by the ecosystem integrity score of 0.71. In comparison, the combined site Manu Alto Purus ranks third globally with a very good biodiversity score of 0.7, But additionally, it is also very pristine with a very high ecosystem integrity score of 0.93. The ranking table can be adjusted by using the sliders on the left-hand side. Allocating different weights to the individual objectives will change the ranking of sites. Using the Select Focal Realm button below the sliders, the table can be subset to show the resulting ranking for the individual realms across all sites globally. The map shows the location of the top sites ranked by their suitability based on the applied weights across the 6 conservation objectives. Depending on the selection, the map shows either the top 30 sites globally or the top 10 sites for a selected biogeographic realm. The white points show the locations for all sites included in the analysis. The red, orange, and yellow points show the location of the top sites, with red indicating the sites of highest suitability. Our aim is to provide assistance in interpreting the data. For this purpose, there is a how-to-use manual, which is displayed in the last tab on the page.
The Legacy Landscapes Fund is a newly established funding instrument that wants to support protected areas and their surrounding landscapes for a time span of 15 years at least. And while we would like to support many landscapes on the planet, we at the moment have funds only for a selected number of sites that we can support. At the moment we have 7 pilot sites, and the Senckenberg decision tool helped us to check that we have actually selected those sites that have a high quality of biodiversity, of forest cover, of integrity and of ecosystem services. And therefore it was very helpful for us in this pilot phase to make sure that we have made a good choice.
The presented framework can be easily extended to include a broader range of macroecological datasets or by adding additional sites into the analysis, making the tool widely applicable to a variety of site selection tasks. One example is the pre-selection of existing protected areas, as we've just shown. Another example would be to look for additional sites that are not yet protected. Looking for those additional sites is especially important when considering more ambitious conservation goals that require the identification of new sites for conservation or restoration, such as supporting the 30 by 30 goal.